Hey guys, it's Mrs. Miner, and so this is part 3 of electrophilic addition. So this is what you do if you have an unsymmetrical alkene. So we actually have two options of products that can occur here because we're going to put the bromine on one side of the double bond and the hydrogen on the other. So option A is we can put the bromine on the carbon 1 and get 1 bromopropane, or we can put the bromine on carbon 2 and get 2 bromopropane. So how do I know what the right answer is? Well, I'm going to tell you now. It's this one. And there is a very good reason for that, and we're going to talk about it as I show you this mechanism. So I'm going to start off down here with step 1 of our mechanism. And in step 1 of our mechanism, we are going to do what we've always done. We're going to have a partially positive and partially negative parts to our HBr. The hydrogen is already partially positive. That's making it the electrophile. These electrons are going to go to the bromine. And the bromine's going to be over here all by itself with both of its electrons, just like we've always done. And over here, the hydrogen's going to add on. But what side does the hydrogen add on to? The answer is that the hydrogen always goes on the least substituted carbon. So the other way that I like to explain this is whoever has the most carbon, or whoever has the most hydrogens will automatically get the new hydrogen. So if I'm going to add on here, this one has 2 hydrogens, this one has 1 hydrogen. That would make this the least substituted carbon because it has hydrogens on it, not other things. So this is where the hydrogen is going to land, making the middle carbon our carbocation. That is called Markovnikov's rule. But Mrs. Miner, why does it do that? Well, I'm actually going to go back to another story that I told you earlier in the week. So remember, this is the SN1 mechanism. So this is the one where we're taking off the chlorine and putting on the hydroxide, but we do it in a much more respectable manner where they get divorced first and then the alcohol gets added on. Well, when this happens, this carbon that's a carbocation is able to stabilize because it has the help of its friends. So these 3 carbons are all loaning their electrons to stabilize or to offset this positive charge, just long enough to get the nucleophile on there and form that dative bond. Same thing is happening here. If I put the carbocation on the end, it only has 1 carbon to stabilize it. But here in the middle, I have help from both sides. And that's why that carbocation is the most stable in the middle. So now we're going to, remember that's our slow step, because we've got to have time for these guys to break up, for this one to take them in, all those things. So down here, we are going to have our hydrogen on the first carbon. We've got our carbocation in the middle. And this is the step, remember, that will go very, very quickly because the bromine is going to take its electrons and be attracted to that carbocation intermediate, that positive charge. So here on the other side, the bromine will be in the middle, which will give us 2 bromopropane. Now, there we go. Now, that's not saying that you won't ever see this 1 bromopropane made. There are going to be some times where they're going to mess up and they're going to put that carbocation on the first carbon. But by and large, the majority of your products will have that bromine on that second